Just doing a little test here just to make sure if in the comment section, if you guys can say, I can hear you and I can see the star and the scribble on Basic Skywarn, just say yes in there and you can hear me loud and clear. That'll be great. Or it could be in the question section. That's fine. I will say that my GoToWebinar is working quite slow today. Okay, you can hear me. It took a while for me to open it up to see that. That is great. I'll go ahead and get started here. I have 159. I'm going to go ahead and erase that and then talk about some of the logistics, at least for the online course. Let me just go ahead and erase all and get to here. And I have 2 o'clock. Thank you guys for coming in. I think we have about 71 attendees that are with us today. This is the Basic Skywarn spotter training, storm spotter training, brought to you by Cleveland, National Water Service Cleveland. I am Freddie Ziegler. I'm the warning coordination meteorologist. I am also the kind of the point person for the Skywarn program. This year, we have a mix, just like last year, a little bit mixture of, last year was a little bit more in person. We tried to get as many as 27 Skywarn classes across Northern Ohio and Northwest Pennsylvania into the mix. And I think we had maybe 1 or 2 online. This year we have 3 online. We have another online course on the Basic Skywarn Storm Spotter training. That's going to be April, I believe, April 13th. And then if you want to get into the weeds of what's going on as far as looking at storm structure and looking at all type of different things as far as how we forecast long track tornadoes, looking at balloon soundings, looking at radio signs, looking at SKU-Ts as far as that. You really want to get into the weeds of that. You can actually view the advanced course that's being offered. This is the first time, from what I understand, by our office. I know other offices have offered it because you've asked for it here locally. When are we going to have an advanced Skywarn? And that is going to be offered from 2 to 4 on April 6th. And I will make that announcement at the end of the course as well. But you know, that's going to be in the same place you registered. It's a different link. So if you want to register for that, that advanced course on April 6th, you just go to that link and register as well. So we'll go ahead and get started here. We do have quite a few slides, about 100 slides, and so I do have a break in there. So I'm north of 50, so I'm going to need a break myself. So we're going to have a break, and I'll be able to answer some of the questions in there. If you have any questions, just put it in the question marks. I will try to get to it either at the break time or at the end of the presentation. So we're going to go ahead and get to it. Let me go ahead and slide this over here, and I got a little topics. Let me slide this over. It's a little slow. I'm a little bit nervous about this because it's the GoToWebinar is a little slow. I got the spinning cycle here. For the topics and objective of this course, definitely I want to push forefront our mission. That way you know what we're trying to do as an agency, as a federal agency, the National Water Service mission, and the information about the Cleveland office. You know, we're one of 2 offices inside the state of Cleveland, inside the state of Ohio, that services Ohio, but there's actually 5 offices that services Ohio. So I'll go over that as well. Why do we need spotters? You guys are very important. That ground truth, we really need that information. Watches and warnings and what to do. We're gonna go over that, give you my spiel. You know, we had a kind of a slide deck that actually showed taco, you know, all the ingredients for a taco, then a taco put together. It was called a watch with all the ingredients spaced out and then a warning. But I'll go over something I've been going over for the last 15 years, maybe 20 years, is doing Skywarns. National and local resources. This is very important. When I was in person in Portage County, I was, you know, these are some of the things that I give information to the emergency managers and some of our partners, and what to look for, kind of a bird's eye view of what's going on. So before you get into the weeds, it's really what's going on nationally. These are national sites that we look at. They're federal sites. They're actually part of our agency, and then of our local resources when we're actually talking to the spotters and emergency managers. Thunderstorm ingredients, life cycles, and types. The types of hazards that occur across the nation and the state. If this was in person, then we'll get down to the local, but we're going to remain in the state. We're talking about Pennsylvania and Ohio. Identifying ominous clouds and parts of storms, and how to report hazardous weather. This is a very important portion here as far as reporting it, how to get that information to us. If you're in the field, if you're out and about, and oh, by the way, there's a funnel cloud, how do you report that? You want to do it quickly, and so we'll go over some parts of how to do that. Our mission, the National Water Service mission, is protect life and property. We do that through the way we issue our products, our watches and warnings. Here in the National Water Service Cleveland office, we have 14 forecasters. That's forecasters that's working 365 days a year, 24 hours, 7 days a week, holidays, Easter, Christmas, New Year's. New Year's Eve is a big one with some of the young people, but we work it all because weather does not sleep. I mean, weather occurs at all times of the hours. Luckily, a lot of the storms that we see down south that occur in the overnight hours does not occur here in the overnight hours. I would say it does, but rarely. So that's one kind of win. We got to get a trade-off. We get the snow here, but they don't get that much snow down there. 5 LTechs and IT personnel here to kind of help us out. We have a lot of equipment and a lot of equipment out in the field to help us, especially at some of the airports as far as observing the weather. 3 administrative and meteorologists, that includes myself, a science operational officer to keep us abreast of what the weather's going on, and also a MIC, or a meteorologist in charge, my boss and boss of everybody else that's in the office. 1 observation program leader, kind of does volunteering as far as helping the volunteering people that actually report weather and kind of QCing it, making sure it's correct before we send it to the National Climatic Data Center and also the Midwest Climate Center at Purdue University. We have a hydrologist with all the rivers and administrative assistant to make sure we get paid. You know, one of the things here, just kind of showing the actual office here. We have 122 offices across the United States, and kind of we'll zoom in a little bit. You can tell we're located right across the northeast Ohio there for our office. We're also located in Guam and Puerto Rico. Our office here, this is actually kind of a view of our situational awareness board there. There's about 12 screens, and actually, you know, sometimes you kind of take an observation and take the time to kind of look. There's almost 67 screens in this room. There's 8 workstations. Each workstation has about 5 screens on their PC, and also what we're looking at as far as radar, looking at models, making the forecasts. We do forecasts for aviation, 7-day forecasts, marine forecasts for Lake Erie. So we do a lot of other things that you don't see in the background. With fire weather, we do that as well. Climate, some climate reports. We do the ice forecast for the Great Lakes. So we do the initial ice and then the growth and all that. So we do a lot of things that's kind of in the background that you may not be aware of. But we, as an office, every office has some uniqueness to it, but most offices carry out the same theme of protecting life and property through watches and warnings. Here is the kind of a bird's eye view of the state of Ohio and the western portion of Pennsylvania. All blue is across Ohio is showing our county responsibility area. That's the counties that we're responsible for. The Cleveland office has 28 counties in our county warning area, and 2 in Pennsylvania, Erie and Crawford. And you can see the yellow, the Wilmington office that covers central and southwest Ohio. The Northern Indiana, that's the office that's somewhat close to Fort Wayne. That covers the extreme Northwest Ohio. Pittsburgh covers Western Pennsylvania and also East Central Ohio. The office in Charleston, West Virginia covers the extreme southeastern portion of Ohio there. So we have 5 offices that actually covers Ohio. And you can see the western portions of Pennsylvania is covered by 3, but you also have Philadelphia and Albany that covers a good portion of the eastern portion of Pennsylvania as well. Let's go ahead and go to the next slide. You may want to take a picture. We are actually, we have a presence on social media, Twitter, Facebook, Instagram. If you didn't know we're on Instagram, yes, we're on Instagram. YouTube, we don't utilize that much. We're going to try to utilize that a little bit more, especially for preparedness and briefings. And also our website. You've been to our website. There's a lot of information on there. If you're new to our website, it can be overwhelming, and at times you just have to get used to it because there's a lot of information on there. It's not like a straight shot, one simple search line there. There's a lot of pull down slides where you can get information, and I'll show you an example of that as we look for some of the outlooks and some of the resources that are available. Why do we need spotters? I think spotters, you guys are part of the warning process. You bring that credibility to the warning. And the reason why that is because it's quite natural for people to see a visual or hear something, and they're more likely to act on that warning. So we're sitting in the office, we're looking at radar, and and there's, radar is getting pretty good at indicating a lot of things on radar. I mean, it can indicate circulation, it can indicate large objects in the air, but at times we do need some verification on the ground, some ground truth, and so that makes a credible warning. Radar, I've worked on the 74C, which was a network radar back in 1974, and actually decommissioned sometime in the mid-90s, but the new, I would say new now, it's actually old, the 88D radar came in. It had the Doppler principles as far as detecting information as it rotates around. The radar beam is actually 32 feet in diameter, the actual dish itself. The beam actually shoots out an electromagnetic wave that goes out and comes back. It's kind of in a listening mode. But what's actually going on is just like the old radar, it's detecting precipitation. And so if the precipitation is big drops, hail, or raindrops, it's going to show up as white, a magenta, or purple, or pink, and red. And then as you get a little bit green and light blues, and it becomes a little bit lighter. So those small particles are dust, bugs. That's come up at light blue. Green is going to be, rain, maybe moderate rain in the yellow and red, and of course the big drops in the pink and white. So you get the idea. But it also listens as it sends the wave out. And so as it sends the wave out, if it comes back faster, that means whatever particles are in that cloud or whatever particles it's detecting, it's moving towards the radar. It's going to show up as a red, and if it's moving away, and if it's going to show up as green. So the Doppler effect is the same way if you're at a train stop and a train is approaching you, and the waves are the sound waves, or the horn is approaching you, has a high pitch. So that means the waves on that, the sound waves are actually coming towards you. They are actually kind of crunched together, and so you get that higher pitch. The waves are crunched together. That means it's going from ridge, trough to ridge, is really fast, and it's crunched together. When a train passes you, that means the ridge is actually farther away, and you get a low pitch. And so that's the same way with the radar, except the radar is the fixed point rather than moving. And so the other objects are moving. So why do we need spotters? Again, everything, the radar can't be the be all end all. You know, everything is a lot more detailed closer up. It's like your eye vision. I can see up close, but you get farther away, your eyes will, you know, will start to fade, not as focused as well. Well, the radar is kind of the same way, kind of the same principle, but not really. The beam is sent out, it's fanned out over time as the beam goes out. It's not a straight shot like a cone, it actually goes out like a wave. And so over time, if you look at this actual graphic, or this graphic here, this is actually a display of the reflectivity. It's showing the storm that's on the left-hand side. It's closer to the radar. And so there's a lot of details you can see in that. That's because it's closer to the radar. The further away the storm is from the radar, the details are not as, the storm structure is not as detailed. So it's kind of smooth out. And you know, as a forecaster sitting on the radar, you kind of know that's happening. But when you have a storm that's moving away from you, it may exhibit some weakening, or it may not. So you may need that ground truth. Hey, I'm going to call up an emergency manager or police department or fire department and see, okay, this storm was detecting pea-sized hail, or, you know, dime-sized hail, and maybe that was the report initially when the storm was closest to the radar, but now it's moving away from the radar. Is it showing the same thing? Now, it may be showing it's weakening on radar because it's moving away from radar and the radar is not a detail. Sometimes we need to make that ground truth just to make sure that's what's happening. And that's why we really depend on some of the spotters. We depend on a lot of people to kind of help us out in that aspect. But we have other radars. You look at that network of offices that are across the area. We have other radars to kind of look at a storm at a different angle. There's some areas that we're gonna struggle with. You know, it's no secret, Northwest Pennsylvania, we use mutual aids, and we use Pittsburgh and Buffalo, and we use satellite to kind of really help us out in those areas. Toledo's another area. We use Detroit, and we use Fort Wayne or North Webster radar to kind of help us out. And we also use FAA radars as well to help us out. So there's a lot of things that we're using to help us out for different areas. And so we not only we have our network of radars, we have the FAA, the Federal Aviation Administration radars to help us out as well. But we can do a lot of manipulation to those radars, so we can see things, and they're very detailed too. But they're closer to big cities, and so we do need help in certain areas there, and that's why we need spotters. The other thing is just hearing, you know, we issuing a warning, and like if there's a tornado warning that's in southeastern Trumbull County in northeast Ohio until 3 p.m., you know, at 2:39, spotter reported a funnel cloud near Hubbard. And so that's going to get a lot of mileage. Radar detected, they like, you know, people like, okay, well, but if they spotted reported, fire department reported, you know, National Water Service employee, that's sometimes that happens too. But a spotter reported a funnel cloud, that's going to get a lot more weight. It's going to get ground truth. And what we're striving for is the public action. We also help from, like I said, mutual aids before. We have help from our neighbors from Pittsburgh, from Buffalo, Wilmington, our neighbors, you know, in Detroit, to kind of help us out either by radar, but also by internal chat. We're talking with them. Hey, we got a storm that's coming, that's exiting our area and coming to your area. It has a history of producing hail. And so that's how we do mutual aid. We also invite the ARES, the ham operators, to come in sometimes to help us out with some of the spotters. We constantly contact with the state of Ohio, Ohio EMA, and Pennsylvania PEMA, the CERT, community response, news networks, and TV meteorologists, Homeland Security. So we're constantly in contact with a lot of different partners, and what we're trying to do is provide that consistent message. So we're conveying the same impacts as far as conveying those impacts and urgency. So we want to create that urgency, especially when we got a storm like you saw a couple of storm that was down south in Mississippi, and there's a lot of team of people, not only the Weather Service, but also MEMA, Mississippi Emergency Management. And so they were all in contact. They're encouraging that public action, and that's to minimize the loss and facilitate recovery on the back end and do it quickly to protect life and property. So what makes a good spotter? You know, I always say in person, we're not training chasers, but we do use their pictures, and I cannot deny on that one, but we want you to remain safe. That's the #1 deal here for spotters, safety and preparedness. Where do we get the information? You got to learn how to get that information and know where to get it, not only from our office, but also from national sites as well. How to identify storm structure, we're going to talk about that. And of course, how to report to us, how to submit an effective storm report, time, event, location. So in a National Water Service watch, a severe thunderstorm watch, that's when the ingredients are there for damaging winds, maybe some large hail, maybe isolated tornadoes. You know, there's all, you know, in a severe thunderstorm watch, the conditions may be low for a tornado, but there's still maybe a possibility. For a tornado watch, definitely tornadoes, the ingredients are there, right amount of shear that's there. We're going to talk about shear, damaging winds, large hail. Flash flood watch or flood watch, that's when water is flowing over the roadways, rapid rises in water, that is a threat of life and property. Be prepared. Now, National Water Service warning, that's when severe weather is imminent or occurring. It's ongoing. So severe thunderstorm warning, the true definition is that winds of 58 miles per hour and hail of 1 inch in diameter. Now you're saying, oh, well, I live in an area that has a lot of trees. You know, it doesn't take 58 miles per hour for a tree limb to come down and land on your car or land or cause some impacts. And so we are aware of that. I think, you know, for the most part, our forecasters are aware of that. And so they do forecast in a sense as far as severe thunderstorm warnings for impacts as well. Tornado warnings, Doppler radar indicated rotation and confirmed tornado reports, either by a spotter, emergency manager, police department, sheriff's office, first responders. Flash flood warnings, 6 inches or more of water flowing over the roadways, and rapid rise of water, that is a threat to life and property. That's kind of, you know, the flash flood warnings and the flood warnings, they're not the, you know, they're not the sexiest one, but like the tornadoes, but they can cause some issues there, and they cause a lot of loss in life and property. So here's my definition. I kind of go into my definition of a watch and warning. I grew up in South Florida, and believe it or not, this is before it was built up. Well, some of it was built up. And when I was a kid, I'm talking about teenage years back in the 80s, we used to go out and actually go cow tipping. And so this is an idea that, you know, you're not supposed to do this, but this is what we did. This is before Nintendo. This is before, well, it wasn't before Atari, but it was way back then. One of the things we did is we tipped over cows. We got in the field and we tip over the cows. So my thing as far as to watch, when we going out there, foolishly going into the field, tipping over the cow, that was kind of in the watch state. Now the cow is angry. Now the cow is charging after us. Now we're in the warning stage. Our action is to run. And so that's what we want, the action. And I know that's my definition of distinguishing the difference between a watch and a warning, and the running is the action. So in safety and preparedness, we all do this in the way we live as far as our life. We look at something or planning a trip and maybe a year off. We have a kind of a broad view of what needs to be done, and we kind of narrow it down over time as we approach the event. And that's the way we do it with all types of weather, not only severe weather, but for winter weather, hurricanes, even for, you know, non-events or non-precipitation events or non-rain events, like a freeze watch. Well, you know, we go into a freeze watch and then a freeze warning. It's kind of the same idea. But for a severe weather, outlook is probably the best way, you know, we kind of get in the idea of what's going on. And our office actually issues a hazardous weather outlook, and we're going to talk about that. We're going to talk about the Storm Prediction Center as doing an outlook as far as storms across the United States, out to 8 days. And also Weather Prediction Center looking for a heavy rain threat for the next 3 days. We're going to talk about that as well. When you get into the watch stage, that's actually about 8 hours before an event, or a kind of 8 hours coverage of the event. 8 hours, maybe 6 hours in some of it. It may be 5 hours. So a severe thunderstorm watch could last 5 to 6 hours, maybe up to 8 hours. Tornado watch, usually 6 hours, could be up to 8 hours in some instances. A flash flood watch, that can vary depending on the threat and how long the duration of the rain is going to be. A flash flood watch can go out as long as 12 hours, even up to 18 hours. It depends on the event. If it's a tropical system, and especially if we get remnants moving up here, getting into the Ohio and Pennsylvania area, that's when you get the long duration of tornado watches and also flash flood watches. As far as the warnings, you get into that stage, that's when it's time to act. Severe thunderstorm warning, tornado warnings, flash flood warning. It's time to take shelter, time to move to higher ground if it's a flash flood warning, time to cover your head, time to go into the interior basement. And of course, as you get into those seconds, saving lives. Together we can save lives and operate safely. So before a severe thunderstorm, just kind of the before stage, it's kind of the severe thunderstorm watch. Is on the right-hand side, you have this is what you'll see on Twitter. If you follow us on Twitter, sometimes you will have these automatic tweets that actually go out. This is from last year, from June 1st, 2022, large box for Northeast Ohio, and actually North Central Northeast Ohio, most of Pennsylvania, Northern Pennsylvania, and Western New York. In the watch stage, you're kind of keeping you're kind of on call, kind of keeping your ears open. You're weather aware in this state. During a severe thunderstorm warning, that is the time to seek shelter in a sturdy building away from windows. You want to monitor for tornado warnings, because there may be a chance that the severe thunderstorm warning goes out. We're talking to the emergency managers. We're talking to other officials. Hey, we're monitoring this severe thunderstorm. It has a broad rotation, so we may be upgrading to a tornado warning. And so you may see that tornado warning come out. So monitor for tornado warnings. In a tornado warning, it is best to go into an interior room or a basement. Most of the storms across northern Ohio and northwest Pennsylvania are going to be on the weak side. That doesn't mean it cannot kill you if it picks up an object and hits on your head. That's why they tell you to cover your head to get in that position. The tornado safety is to get under a sturdy stairwell or in your basement, in between those walls, or where you have two division of right in the basement there for a sturdy place, and wait until the warning expires. Afterwards, you want to be safety first as a priority. Don't rush out to find damage, especially for these fall type storms where there are a lot of leaves down. There could be power lines down too, and you may not be able to see them. So you need to be careful in that situation. Lingering lightning as the storm is exiting, you still could have some anvil lightning that's left over. That's very dangerous. Trees and water across the roads. You may not be able to drive around, even if you don't have any damage to your home. You want to drive around, or you know that there's damage around you. The roads may be closed due to water over the road. And be careful around weakened structure. You may want to wait for a first responder to rescue you if your building has been damaged. So I'm going to talk about our first resources here. This is actually your Storm Prediction Center. This is a national center, kind of like the Hurricane Center. This actually monitors storms across the United States. And so this is the front page. This is, you go to Google, it'll be the website is www.spc.noaa.gov. If you go to Google, just type in SPC, it should come up. And this is what the front page looks like. Over here on the left-hand side, I have the second tier. I have convective outlook, or CONV outlook highlighted. You hover or you click on that mouse and you will get the full 3-day forecast for thunderstorm outlook across the United States. And that's very helpful because you can tell what's going to happen as far as the threat. It's an outlook. It's not actually, in a sense, it is a forecast, but it's kind of an outlook. Is it a general thunderstorm? And I talk about the different threats there. So on this particular day, this is a SPC day 1 categorical outlook. So this is what it looks like. This is taken from December of 2021, December 11th. This is in the morning, that morning of the Kentucky tornado, the long track tornado that was struck in the overnight hours after midnight. And so these are the rates here. The actual legend is on the right-hand side. It gives you the category outlook legend. It goes from TSTM, this general thunderstorm. So that's a light green. That's thunderstorm with no threat of severe weather. And you kind of march up to marginal, slight, enhanced, moderate, and the highest being high. And so on this particular day, you can see it's kind of contoured right around the southeastern Missouri, southern Illinois, western Kentucky, western Tennessee, and northeast Arkansas. That area there was under a moderate. That's where the Storm Prediction Center thinks that that's your highest threat of severe weather. Here's the severe thunderstorm risk categories, and it's actually that legend that I had down there on the bottom right. It's expanded, and it gives you the colors and what to expect, and it kind of gives you kind of a march through there from thunderstorms with no labels, meaning it's just general thunderstorms, to high, indicating widespread severe storms expected. Also, especially in day 1, the Storm Prediction Center will kind of split up those threats. And what I mean by split up the threats, it will actually give you information like the wind threat. Is it a thunderstorm wind threat existing? So this is from June 13th, I believe, and it's showing a pretty good wind threat that's across northern Indiana and northwest Ohio, I believe, and extending all the way over to West Virginia and western portions of Pennsylvania, all across Ohio for the most part, and the highest threat in northwest Ohio and northeast Indiana. And it's got hatched out there, and the legends on the bottom, it shows that there's a pretty good threat of that northwest flow occurring. That was the storms that occurred on June 13th, I believe, or June 12th and 13th, where we had quite a bit of wind damage, and we had a pretty good thunderstorm complex and a derecho that moved across. The middle there is showing the tornado threat, and so you're looking there. You can kind of strain your eyes there, but just to give an example, it's showing 2% and 5%. And you're thinking that's not that high. That's 2%. It's 2% within a 25-mile radius of 1 point, and so that's not high, but most of the time you're under 0%. So 5% is getting up a little bit higher. Then over on the top right, is showing the hail threat. So it's showing a hail threat of 5 and 15%. So the wind and the hail is definitely higher, wind being the highest on here. These graphics are from the same day. It's just split up as far as the threat: wind, tornadoes, and hail. Now we're going to go to water or flooding or the threat of excessive rain. And so the Weather Prediction Center, which is located, the Storm Prediction Center is located in Norman. The Weather Prediction Center is located in Washington, D.C. or Silver Springs, Maryland area. You type in WPC, NCEP, NOAA.gov, then you should be able to get to the page here. This actually deals not only with rain, but also precipitation. We're talking about ice and heavy snow. So we monitor this quite a bit as far as outlook, and it gives you an idea of what's going on as far as, is there going to be some heavy rain across the area, especially in the warm season. We're getting kind of in the area, time of year where we need to monitor it more often. We've been, we didn't have a lot of snow in some areas across northern Ohio, but we did not skip out on the rain. We've been pretty good with the rain coming across, and so we're kind of setting ourselves up for maybe having some excessive runoff if we get a heavy rain to set up. So this is what it looks like. This is actually day 2. Here's to give an example of what it looks like. It's kind of the same idea as the severe weather, but it's only 4 instead of 6 categories. And so it just has a marginal excessive rainfall for 5%, 15% for slight, moderate 40%. And so to give some examples on a moderate to high, the flooding that occurred in New York back in 2021, I believe, for Hurricane Ida, that was excessive rainfall, and they were doing some rescues with that. So that you can get an idea of how what it's trying to scale on as far as the rainfall and how much excessive rainfall is going to occur over a general area. It's kind of just an outlook. It's not the watch, but it's actually a national view, a bird's eye, a way back bird's eye view of what's going on across the lower 48s. And then now we're going to get to more local. This is our website. This is the front page of our website. And so it's going to be weather.gov/CLE. That's going to get to the front of our page. If you do weather.gov, you'll get the National Center, National Weather Service for the whole United States. You click onto any location across the United States, you're going to get the local office in that area. You'll click on Northern Ohio, Northwest Pennsylvania, you're going to get our office. And so most offices look the same. They're going to have the bars across, and they're going to have information. It's going to look a little different depending on the weather, but this is how we're going to get to our statements when we're talking to the emergency managers and we're talking to the spotters. So you're going to use the current hazards, click on that, and it's going to pull down that scroll bar, and you're going to click on the outlook. The outlook is going to get you to the hazardous weather outlook, and this is where we're going to be talking to the emergency managers, and we're going to be talking to the spotters, and so in a text format. And so this is what we're typing out each morning in the pre-dawn hours, maybe 5 or 6 o'clock. This goes out, we go out, and the emergency managers will see this. So on day 1, we're a little bit concise, we're a little bit more detailed of what's going on weather-wise, what's going on, where we need help, what's, what we're thinking are going to affect the area for the most part. So here's an example just showing flood watch, listen to No Weather Radio for more information, stuff like that. It may get a little detail in the weather. You can see in day 2 through 7, we actually forecasted impacts all the way out to day 7. We're talking about a system on Monday and Tuesday will bring a round of warmth and rain, potential for flooding. So that kind of gives you an idea. I need to be worried. I need to possibly staff up if you're an emergency manager, or just everybody stay nearby. Don't go anywhere out of the area. We may need some help as far as assistance and support. So that's kind of the way we're talking to the emergency manager. Down at the bottom, we're talking to the spotters. Spotter information statement, spotter activation is not expected at this time. That's usually mostly what it's going to say. But in any event we do have the spotter activation, we will actually call out the ham operators to help us out in the office. And we may say spotter activation is needed across Northeast Ohio, spotter activation is needed across Northwest Pennsylvania. That kind of statement is going to be in there as well. Spotter activation is needed for snowfall reports. Stuff like that is going to be in that spotter information statement. So we have the hazardous weather outlook, but we also have the experimental graphic hazardous weather outlook. This has been out for at least 8 to 9 years. I'm not sure why it still has a moniker of experimental, but this actually breaks down all the hazards for the first 24 hours, but some hazards go all the way out to 7 days. And so the left-hand side is showing the highest risk impact and a default to that. So it's showing lightning risk for Monday and Monday night. This is not current, so this is just an example. This is February 23rd, but it's also, if you go here, it's just like the red light, green light, green being go, yellow being, cautious, red being highest. And so it's going to show, for each day, you see that today, you can scroll down, you look at all the parameters there. This is based off of our grids, what the forecast is forecasting. So some stuff may not be mentioned in the hazardous weather outlook. That may not be an impact, and that's okay. it may show up here. So a wind feature may show up here. Maybe some fog will show up here. Maybe some excessive cold is showing up on day 5 or day 6. It's based off our grids. It's what we're forecasting. And so some of those impacts may not show up in the hazardous weather outlook in the text product is what I'm trying to tell you. So if you scroll down, you'll actually get this risk level and category. Give you an idea of what the categories mean and what it actually means as far as the definition. So let me step back here. This is the front of our page. This is showing the local outlook. Just below the local outlook is showing the graphical hazardous weather outlook. So they're right below each other there. And so you're able to look at both of those right in the same area. Not to be outdone, I actually got a no-weather radio back when I was about 9 or 10 years old. It was from Radio Shack. It was kind of a box. Just click on it and gives you the weather. No-weather radio is still supported and still very much a primary backup, especially if the weather is knocked out of power. It can be programmable now, so you don't as soon as we town bursts, it just town bursts, sound bursts everywhere. You can actually program it for your county. It's backup, especially if the power goes out, and it tone alerts almost like an alarm clock, an old alarm clock from 15 years ago, and it'll go off and you press it to get the information of where the warning is. As you know, the National Weather Service does not have an app. You may have seen, maybe on some of and I get it on my social media, some of these NOAA hazards radar and stuff like that. That is not us. That is someone else that's using our logo, and they're not allowed to use our logo. But at this time, you may see that, but we do not have an app. Even they may have it in the App Store. FEMA does have an app. They have all of the alerts from the National Weather Service up to 5 locations, so you can actually program it for you. You can program it for your kids, or you can program it for your parents. Red Cross has one. It has 2 apps alerts as well for Apple and Android. They have over 35 different types of severe weather. Yeah, that's 35. Definitely don't want a volcanic and ash alert or a tsunami. So we don't have those. Those are things you don't have to worry about. But the tornado watch and warnings are definitely on there as well. So it has different types of the way to alert you. You may have already heard I was actually doing a Skywarn in Portage County, Ohio, last week. We had an Amber Alert right in the middle of the Skywarn, and we have about 80 people in the room, and all their phones went off at the same time. Well, the National Weather Service has a way of actually activating the wireless emergency alert. We're capable to actually alert on your phone. It's built into most cell phones, all smartphones, but also some of the flip phones are on there too. So they have that capability. I see some of the Weather Service offices have a way to activate it. I think for the most part, it's defaulted, so it is activated. As of right now, I'll be honest with you, as a layman, as a person that's actually, that's sitting out there and have my phone, I don't get enough alerts, so I'm going to turn it off. I do monitor for Amber Alerts because I look to see if I can help somebody. Anytime there's a tornado warning, it will alert you. We don't get that many tornado warnings, especially from one location. Flash flood warnings with a considerable tag, that's flooding that's a little bit more widespread than just covering the roads. And then now, in the last 2 years, they've added the severe thunderstorm warning with the destructive tag. Those are where we have storms that are capable of 80-mile-per-hour winds and baseball-sized hail. So those are very rare situations that we're going to use that. We used it about 4 times across northern Ohio and northwest Pennsylvania. And in all of those cases, there was widespread wind damage for all of those cases where there were a lot of trees down, a lot of snap trees, power lines down, power outages out for 3 and 4 days. And so that's where that wireless emergency alert, it comes in very handy. I call it one of our most useful tools, one of our tools, one of our ways to communicate, one of our tools that in our toolbox to actually get the message out. I think it's a very useful tool to cut through a lot of everyday living, and it alerts you on your phone, and it's cross-generational. The no other radio, for the most part, young people do probably buy no other radios, but the no other radios is mostly, it's a little bit more age-based. But phones, everybody has a phone, from boomers, even some solid generations, they have them. Gen X, Gen Y, millennials, all the people have phones, and so it's cross-generational. It gets to everybody, and that's why I really like it. So we're going to talk about thunderstorm ingredients. This is definitely getting close to a break here, about 44 after, so I just want to make sure I just don't go over too long here. I'm going to talk about thunderstorm ingredients. For thunderstorms, especially this is from Visala. The report is, this is kind of a given idea of thunderstorm day, the map on the left-hand side. And to be quite honest, there are thousands and thousands of thunderstorms worldwide at a given time. The percentage of storms to become severe is very low. Large hail of 1 inch is very rare. Strong winds of 58 miles per hour, they're very rare. And tornadoes are very rare. But because we have so many thunderstorms, we do have some storms that reach severe limits. No place in the United States is immune to the threat of severe weather, and I can say that on the calendar. There's no time that's actually there too for the state of Ohio and Pennsylvania. 2 years ago, or a year and a half ago, in December, they had tornadoes in Minnesota, and Minnesota, as far as last time I checked, was farther north than Ohio and Pennsylvania for the most part. On average, we average about 35 to 45 thunderstorm days across northern Ohio and northwest Pennsylvania. Actually, a little bit lower across central and eastern Pennsylvania. So you can see those numbers are not very high, 35. We're talking about if you get a thunderstorm at 3 o'clock in the afternoon, that counts as a thunderstorm day. And in June, and of course, summertime is going to get a little bit higher, and of course the transitional season, spring and autumn or fall, we're going to get some of those days as well as the fronts start to, season starts to transition. So we're going to talk about the thunderstorm ingredients. The three main ingredients you need is instability, moisture, and lift. And for severe storms, wind shear is required. So we're talking about the life cycle. Definitely in the towering cumulus stage. Just take a typical summer day. You're kind of looking at the clouds. You see kind of these clouds bubbling up, and now they kind of have a little bit more to them. They got a little bit more. They get a little bit more vertical extent to them. They get to a towering cumulus stage. They start to grow a little bit, so they're becoming vertical. Starting to get that updraft. It's predominantly updraft going into that storm. There's no rain in it. It's just clouds are just developing because these warm, moist eddies, more moist buoyancy of air are going up. And so as you get to the mature stage, continued moist air coming up, you're starting to get precipitation process occurring above the freezing level, and you start to get downdrafts. So not only get the red arrows showing the updraft, and also you get the same amount as the downdraft that's occurring. So you get to the dissipation state, the over theme there is predominant downdraft. So it's raining itself out, it's dissipating over time. This can be dangerous because if you in the mature stage, you have lightning strikes that are occurring, and the dissipating state, the lightning strikes are less frequent, but they're still occurring, and you could have a lone strike that occur 15 minutes after everything you think is done. And oh, by the way, there's a lightning strike that occurred that surprises everybody. So that could happen in the dissipation state, and that's a danger. So in the single cell storms, that's when you have that one updraft that's occurring and the downdraft. And the lifespan is about 20 to 45 minutes. Generally small hail, gusty winds, and heavy rain is going to be the threat, but it's going to be a short duration heavy rain. So it's going to rain, and then it's going to rain itself out. This is what you see in the field. You're kind of looking out, and you see the actual rain shaft, the darkening there that's occurring. You see the anvil up top, and you see that updraft that's occurring. It hits the tropopause or hits the warming of the atmosphere, and it kind of flattens out. That shows you the anvil, the thunderhead of what people call it in the field, but it's actually the anvil portion of the storm that's flattening out, and then it rains itself out. It rains on top of the updraft. This is what it looks like on radar. So not a very isolated stage, but it's very isolated to scattered storms across. This is from our radar that's showing across northern Ohio and western Pennsylvania there. I think it's a mosaic. I think it has Pittsburgh as well on there, Pittsburgh radar on there. So now we're going to talk about multi-cell clusters. Heavy rain is going to be the main threat, especially if there's a training effect of storms developing and raining itself out on the same area. And you can have the flash flooding threat could be there. If they're moving slow, it could be there. There's a wind threat and a hail threat. The tornado threat is relatively low with a multi-cluster. I can't rule it out, but it's going to be relatively low. This is what you're looking at. Looking out on the cornfield. To the left, you see the oldest and weakest thunderstorms occurring. And there you may see some flattening out of the anvil, maybe the raining, and you see maybe some clearing at the base of the clouds. It's still kind of dangerous. You could still get some lightning. In the middle, you see that nice bright knuckles at the top of the storm, actually getting to that tropopause, kind of flattening out, but those nice, strong, bubbling knuckles there, and you can see it there. It's still exhibiting that strong updraft that's occurring. And then you have new growth that's actually showing off on the right-hand side there, starting to get some development, still growing, maybe not showing precipitation at the base. So you may not see any precipitation at the base on that one, as you see in the middle with the strongest storm. So this is a actual radar shot across northern Indiana. This is going to northeast Indiana. And it's showing a lot, and this can be messy when you're looking to see what's going on. Definitely the heavy rain threat's going to be there. You get a lot of storms developing, also dissipating at time. You may have some storms that could have some hail. If you have any hail there, maybe some nickels or maybe some dimes or even some pea-sides, you may want to call that in, because we can kind of gauge what the radar is showing. And for that next storm, if the storm is stronger than the storm that you reported on, it may be approaching severe limits, maybe getting up to 1-inch size hail. So that's why it's always important not only to report severe weather, but stuff that's sub-severe as well in the hail portion, as far as hail size and stuff like that. So on a multi-squall line, these are what we call these thunderstorm complex that has that right ingredients of updraft and downdraft, but they're not cutting off each other as far as cutting off the updraft in that storm. The wind is going to be the biggest feature as far as the threat level. Hail is going to be there as well. Heavy rain, and there may be some isolated possible tornadoes along the leading edge. And you can have some brief spin-ups. They're not going to last for long, and they're going to be very tough to detect at times. And so really gotta depend on a radar operator just really looking at things and kind of detecting it and acting really fast. But also from the field, we get those reports. That's something that we need to act on very quickly rather than stalling and waiting for additional reports. If we get reports on the leading edge, hey, there's a tornado, a lot of times the forecasters here are going to jump on that and issue a tornado warning, because those are actually really brief in the spin-ups and then they're gone. So here's what you see out in the field. This is actually a shelf cloud, or, it's kind of moving in. The storm's kind of approaching you. So this is what you see. This is what we see. This is actually from June 13th and 14th. 13th and 14th in the overnight hours. You got one cluster of storms that's moving across the central portion of Ohio, northern portion of Ohio there. And so what I want you to concentrate on, this line is moving in, and see those two red lines, and we'll watch it again as it moves through. The second cluster moves through. So The yellow boxes are the severe thunderstorm, and those reds are tornadoes. Right on the leading edge, those were tornado warnings. So the yellow is the severe thunderstorm. The red are the tornadoes. Now I'm going to talk about supercells. They're responsible for the most significant for the tornadoes, large hails, larger than golf balls. All threats, all modes of severe weather are on the table. Wind, hail, heavy rain, and tornadoes. This is when we have extreme winds and flash flooding. And so you see that nice structure there. We're going to talk about a lot of the features there as far as recognizing the difference between a wall cloud and a shelf cloud. That's going to be a little bit later after the break. So this is what you see. This is what we see as far as the big picture. Definitely see a supercell, and I actually took a picture on my radar scope on my app there of the storm that affected Rolling Fork, and it looked exactly like this. If I could draw on this, it's actually, let's see if I can try if it's going to be slow on me or not. And yes. So let's see. So down here you have the little picture here. This is the wall cloud here. It's not showing up, it's in brown. That's great. So let's get a different color here, see if I can choose a different color. It is not going to give me a different color. Let's do highlight. Let's see. Oh, okay. So that's the wall cloud there. It has a rain shaft that's kind of feeding in. So I just want to give an idea. In this area, that's when you don't have any kind of rain in area. So we're looking at this area here where it's not rain. I'm drawing on the radar now. So this area here where it's rain-free. Here is your rear flank downdraft here. This is where on the back side, this is your forward flank where all the rain is occurring. Of course, where you're possibly where a lot of the shelf cloud is going to be located. Your wall cloud is going to be located in the middle here. This is where a lot of the hail is going to occur, right in this area here. And so it's going to be back here. This is going to be raining out, spreading out to this direction, in that direction, and then also spreading towards the wall cloud. You can see towards the wall cloud there. So I really messed that up. So let me clear it out. We're going to talk about that a little bit later. Clear. And okay, so we're going to talk about thunderstorm hazards. Again, the definition of a severe thunderstorm is 58 miles per hour, 1-inch hail, or tornadoes. Lightning and flooding are other threats associated with it. And so a thunderstorm, we're talking about straight line winds, outflow winds from a thunderstorm that blows in one direction. And they can chop off trees like that and down power lines, and it mimics a tornado if you're very close. But if you kind of look away, you can kind of see where all the trees are blowing in one direction. So you see that downburst wind that's blowing everything in one direction. So that's what's going on there, diverging. And you can see these are fingerprints when you kind of get in a drone or maybe a helicopter or bird's eye view. You see what's going on in the damage. You can see it in one direction. Or tornado is going to be a very detailed path that's concise. So derecho, those are new cells continually forming on the edge, and the rain and hail following behind it. So the updrafts and downdraft along the line are very strong, resulting in large hail and strong damaging winds. As you know, last year, especially in central Ohio, there was a lot of areas that had down trees in one direction to the east and east-southeast. A lot of power lines down, a lot of power outages for 3 or 4 days. And we're showing the same, this is the same one on June 13th going to June 14th. Derecho, the definition, 240 miles must be exceeded. They usually last about 6 to 8 hours. 58 mile per hour wind, 58 mile per hour wind gusts, but usually it's around 75 to 80, and they can exceed up to 100 miles per hour. These are the reports of that day, so a lot of clustering across central, north central Ohio, not much in northeast and northwest Pennsylvania, but a lot of damage across northeast Indiana and northwest Ohio there. We're going to talk about hail. Hail is the formation. I would say this, most thunderstorms have hail, just depending on how high that freezing level is and when it rains or when it starts to precipitate out, if it's going to melt before it reaches the ground. So I've been caught out in the rain. I've been caught out in the rain in the summertime, maybe in a thunderstorm, and the rain hits you, and it's very cold. You're surprised now. Well, wait a minute, this is real cold. So it's coming from the upper parts of the atmosphere where it's super cool water droplets, or it was hail and melted before it reached the ground. And so on the lower right, you can see the pea-sized hail that reached the ground. And you can see the kind of opaqueness, and then maybe a little layer behind it. And then you see a hailstone that actually, you see that nice white opaqueness there. That may be one trip up the storm, maybe two trips up the storm. And then it cools down and maybe get caught back up in the updraft again. And it takes another trip and it grows over time. And so that's what's happening when the hail gets at a larger stone, becomes a larger stone. These spikes are, with hails and other smaller hails are sticking on the hail. And so it becomes spiky there. So now we're going to talk about tornadoes. Everybody want to talk about tornadoes. Annually, the United States sees over 1,200 tornadoes. That's quite a bit. We talk about other areas across the world, and I see some reports, I see a tornado in France, or I see a tornado in Africa, and it's usually one, maybe two. But in a situation for us, we can have days where one system's marching across the plains in southeast and many of the Atlantic states, and it's produced a family of tornadoes of 20, 30, 50, 80 tornadoes over a 3-day period. And so that can happen. So that's why those numbers are so high. And tornadoes can occur any time of year across the United States. For our forecast area, this is northern Ohio and northwest Pennsylvania, we average around 6 per year. So this is the EF scale. Most of our storms are in the EF0 to EF1, about 77%, 80% of the storms. This is across the United States, so this is to give you kind of a scope and idea. Those are weak tornadoes. EF2 to EF3, those are strong tornadoes. Those are 111 to 100. Up to 165 miles per hour. Then the EF4s and the EF5. This is what we call the tornadoes that cause the fatalities for the most part, especially if you're taking the precaution of going inside a home and it's destroying the home completely. The EF4s, there's an example of that was the one that hit the Rolling Fork area where a lot of those homes were totally destroyed. And you say, well, some of those homes were at a weekend stage, some of them were mobile homes, but some of that, as far as I know, were mixed communities where they had mobile homes and brick homes as well. And so some of those homes and walls caved in on each other. There was maybe one wall, an interior wall that was there. Surprisingly, there was like 9 or 10 people that actually perished in that storm for the Rolling Fork area. I have family, and my in-laws are from the Mississippi Delta, so I kind of know the area a little bit. I've never been to Rolling Fork, but I know how some of it looks like a mixed community as far as homes and structures. And so, yeah, it looked pretty devastating down there. And so that was the EF4 that hit that area. The EF4s and EF5 are the storms that cause the most fatalities. But I will say this, an EF0 can cause a fatality if you're not careful, if you don't cover your head, if you don't get out of harm's way. So without saying that any tornado can kill, and don't take them lightly. So this is our tornado climatology. Definitely for the United States, like I said, it's around 1,200. This is actually from 2012 to 21. I kind of updated these slides. If you actually been to a Skywarn last year, we had it for 30 years. I truncated it, and actually Storm Prediction Center had a nice job of actually truncating it to the social media time, 2012 to 2021. And that's when a lot of reporting really increased. The threat of especially our detection has increased as well, especially for those smaller storms. And so our numbers is, if you actually viewed our spotter training last year, we had 19 for the state of Ohio. That number has increased. Pennsylvania, I think was 17. I think it's up to 19. So as of right now, the last 10 years, the average annually is 19 for Pennsylvania and 25 for Ohio. The state of Texas has the most tornadoes because there's a larger area, but the state of Iowa has the most tornadoes per square mile. Not to be outdone, flash flooding is definitely a threat. I always say, you look at this photo, this gift to the north, to the right hand side. You see 6 inches of water that's flowing, covering the road. And oh, by the way, there's barricades there, and that car or that Avalanche, Chevy Avalanche is there, not a Honda Civic, is being taken away from the rushing water there. So definitely look out for washed out roads. You may not know it's washed out. There's forced evacuation and definitely structural damage that could occur. So our motto is to turn around, don't drown, especially when there's water covering the road. Lightning threats, we don't issue for severe lightning, and it's been a generational shift over the last probably 30 years. It's taken 30 years for this to occur, but I think this generation, as far as protection, I've had my kids on soccer fields, and that alert goes off, and approaching storm, that's when it's very dangerous. When a storm is approaching, that's when the risk is increasing, but our reaction to go in is very slow. So that intersection there, right as a thunderstorm is moving overhead, that's when the risk is at its highest. And then as the storm is exiting and people start to venture out, that's when the risk of fatalities can occur as well. So we're looking at this cause, definitely when you get below 20 degrees, that's when the separation there's a little bit more science in there, where the ice crystals collides in the clouds, and lightning does not make a thunderstorm severe, no matter how vivid it is, but it can be impressive, or it can be, I don't know how vivid it is, how impressive it is, but it is deadly. And if you have a lightning death, that's when you want to call it in, or lightning that causes a fire, you definitely want to call that in. So we have reached our break. I have 3:05. I'm going a little bit over, so I'm going to try to answer some of the questions as well. I'm going to come back at 3:10 and we will resume, but I will try to get in here and try to answer some of your questions in here. And the second half is a little bit shorter, so we have time to kind of interact and actually get some more information. Okay, welcome back. Welcome back. I think I had my break, and so we can get back into it again. I'll see if I can push this back over here. It's a little slow here. It says I'm still muted. Let's see here. The software is a little bit slower than I would like. Let's see if it catches up here, and then I'll get started. I want to make sure it catches up, and I think we are back. Okay, yeah, we're back. Okay, so we'll get back to it, and this is a little bit shorter here. And let's see here. So we're going to talk about weather disasters across the area. You know, it's like life and property. I think the assets of our people, of what we do here at the National Weather Service in Cleveland, are the most important. I try to take care of them as far as inside the office and talking to the emergency managers, making sure they have all the tools they have and need as far as getting the information out. We're always talking about resources and making it easier, making sure information is easy. But as we kind of moved in the last 30 years, we become vulnerable, at least on the coastline, but also in other areas as well. So the weather is changing. What, for whatever reason you want to tell, we want to say why it's changing, but the extremes are here. And so this is from 2022. These are all the billion-dollar weather and climate disasters that have occurred across the United States. And you can see a good deal of them are not just hurricanes, they're tornado outbreaks and they're severe weather outbreaks. Oh, by the way, if you look over in western New York, you see the actual winter storm that occurred, excuse me, the winter storm that occurred on the 21st and 26th, the 5 feet of snow that occurred in Buffalo. And that caused a lot of damage. That storm there is especially for the Northeast, for Michigan and Ohio, Pennsylvania, and New York. It caused a lot of strife as far as the damage. Look at the Kentucky flood there. It caused $1 billion of damage. Now we're going to talk about the people here. One of the questions and I'm afraid to, because my software is working so slowly, I asked this question as an example, and you probably can, you could say yay or nay if you knew the answer. As far as weather fatalities across the area, this is from 2021, so not 2022. What do you think is the highest fatality as far as weather damage? And you could actually put that in the question, what type of weather has caused the most fatalities across the United States? Go ahead and put that in there. I'm going to wait for about maybe 20 seconds, and I'm not going to manipulate the actual webinar because I'm afraid it's a little slow. But just go ahead and put your answers there. Just kind of testing you a little bit. And we're not talking for the state of Ohio or Pennsylvania. We're talking for the whole United States. What do you think is the highest fatality? Give it 20 seconds there. So I'm going to give it 20 seconds is up, and I'm going to push this out. This is from the weather fatalities for 2021, and guess what? Heat is on there. And heat fatalities, remember the event that occurred across the extreme Northwest, Pacific Northwest, and Western Canada. That caused a lot of people died in that situation. Not only the fires out there, but the heat and people without AC. Most of the countries over the last probably 20 to 25 years, especially after the event that occurred in Chicago and Milwaukee with the deaths in the mid 90s, a lot of the Midwest and the homes and stuff like that, they kind of gotten ACs in there. So, I have my family that's in Michigan, that's in between Saginaw and Flint. They didn't have ACs when I first married into the family, but they have ACs now. And so that's been a trend over the years, but the Northwest did not. So they had a lot of deaths that occurred. But look at the average, 148, that's a 30-year average. That's higher than everything else. Flooding is the next threat. And of course, it's kind of, if you look at the 30-year averages, tornadoes is coming in third. But we're starting to add some other stuff on there as well. Look at the fatalities for coal. That's the Texas event that occurred. And so that's kind of baked in. Remember, this is 2021, not 2022. So uh, definitely geez, a lot of deaths that occurred, but these numbers are not as high as they used to be. Lightning used to be way up there when we were more of an agricultural type country where we did a lot of work outside, whereas now we do a lot of work inside. So you see we had 11 deaths of fatalities in 2021. Our 30-year average is 37. Our 10-year average is 23. So you get an example. The lightning deaths are going down. We're working more inside. You can look at hurricanes. That's baked in. The 30-year average. Katrina is in there, so you can see that number is actually kind of high. But every year it's actually around 10 for the last 10 years, and fatalities for last year was 12. So, you know, heat is a silent killer. It sometimes it takes some time for those numbers to get in there. Cold is there as well. You can see rip currents. Definitely, if you go down to the Florida Panhandle and the Outer Banks of the North Carolina, that's where we have a lot of rip current deaths occur. So I spent enough time on that slide there. How about fatalities across Ohio? This is for 2021. 2022 is not in there. Most of the fatalities were due to cold exposure in home without heat, 7 of them, and 1 was due to wind, not severe winds from a thunderstorm, but winds from synoptic winds where it blew down a tree on a van and killed a man in Geauga County. What about Pennsylvania? 6 fatalities due to the weather in 2022, and actually those 6 fatalities and 24 injuries were due to a snow squall that was over highway or Interstate 81, and that caused a 80-car pileup exactly 1 year from today. So, you know, when I was creating the slides, I didn't know that was going to come up, and I'm like, whoa, that was on this year. I had to check the numbers just to see if I had the right thing, and I did some searching on some of the newsletters, and yeah, it was on this day. So severe weather across the United States in 2022, almost 21,000 total reports. 1,300 were tornadoes, 1,331. Most of it was wind, 15,000 reports of wind damage, and 4,400 of hail reports. You can look at those numbers where you can see the clustering across Mississippi and Alabama, across the Arklatex and Oklahoma, Louisiana, Arkansas, and eastern Texas. Look at the high plains, they're still there too. And some of those areas you can see across the Ohio Valley, you still have some. You know, we didn't have quite as many tornadoes in Pennsylvania last year. And we're going to look at those numbers a little bit closer. So we're looking at the hazards now. Now we're going to kind of burrow down to the state level. So in the state of Ohio, we had over 722 reports. That's including wind, hail, and tornadoes. Of course, wind's going to make up most of the reports. That's where most of our reports are going to come from. Hail is going to come in second, 60 reports. And remember, the 10-year average norm was around 25 for the state of Ohio. So we were up in 2021. We had 37, 2022, 32. So we had quite a few across the southwest and southern half. The southern half usually gets a little bit more than the north half. What about the state of Pennsylvania? The state of Pennsylvania had over 546 reports, a little bit less than Ohio, and I say across Ohio, but it was across Pennsylvania there. Those are 546 reports. The total reports of 400, almost 500 reports were wind reports, hail reports 43, and only 7 tornado reports. So not that many tornado reports this time, and of course the average is around 19. So that's well below average for the state of Pennsylvania. So now we're going to talk about the ominous, identifying ominous clouds. And of course, what do we mean, how and when to report to the National Weather Service? We're going to talk about tornadoes and funnel clouds, wall clouds, shelf clouds, and roll clouds. And of course, Scud, lookalike, scary looking cloud, cumulus fractus, those false reports that we get all the time. But we're going to talk about that. We're going to talk about its context, rotation. Is it touching the ground? Is there debris observed? Is it sloping towards or away from the rain? So we're going to talk about all that as we get into it. So we're going to talk about the supercell. We're talking about this is the storm that causes all the problems, causes all the fatalities, the wind, all modes of severe weather. So it forms an environment that's highly sheared. So that means it's got a nice southerly flow, or a southerly flow is going in it, but also you have the turning or veering winds with height, as you have at 10 to 15, maybe 20,000. Those winds are actually out of the southwest, and then westerly and maybe possibly northwesterly as you get into around 25,000 feet. And so that veering with winds, that supports the storm, the steering that's not over the updraft. So the updraft is coming from the southeast, but you're moving the storm east, and so it continues, and you have that continuous of that, the persistence of that life of that storm. The supercells have a persistent rotating updraft that's going to be right above the wall cloud. That's going to occur. Supercells can attain the speeds of 100 miles per hour. So those storms that was last Friday, they were moving last Friday across the deep south. They were moving 55 to 60 miles per hour. They can produce large, giant-sized hail and, of course, violent tornadoes. Updrafts, they can produce downbursts with outflows in excess of 100 miles per hour. And, of course, there's a risk of tornadic storms and supercells as well. So we're going to talk about shelf clouds and roll clouds. Horizontal shelf clouds on the leading edge of the thunderstorm. So that's when the storm is constantly approaching you. You get this spaceship type cloud that's approaching you. And then also you may get some wind and some hail and some gusty winds and hail and heavy rain, that cold rain that sometimes you get caught out there, and you may be at a store or you're out and about. So we're going to talk about this area here that's actually to the right, the lower right. It's going to be kind of the downdraft where it's occurring. It's actually spreading away from the main portion of the storm, but it's actually, if the storm is approaching you, it's advancing, and so that's going to be the front portion of the storm, that cool air, that spaceship that's approaching you. Looks like a shelf cloud. It's very ominous, but it is something that you do not need to report to us. You just need to know how to identify it. So the storm is actually pushing, not only it's raining down, but it's actually spreading out, hits the ground, spread out, it's cold and dense, descends, and then the warm moist air is less dense, it rises above, and the shelf cloud is born. And so I'm kind of doing this with my motion here, like I'm in person, but actually the continuous of that cold, dense air undercutting that warm moist air as the warm moist air goes into the storm, and you get this kind of horizontal roll reaction or rotation that's occurring. Sometimes this interaction causes a horizontal rotation, almost like a roll cloud, but it's a shelf cloud. They're interchangeable for the most part. So this is a roll cloud that's actually, the storm has completely collapsed, but the roll cloud is not going to go anywhere. It's going to continue to propagate and continue to move out, but the parent thunderstorm has collapsed for the most part. So it's continuing to propagate, and you may not get that cool air because the storm has really collapsed and they actually run out of gas for the most part. So identifying the shelf cloud, the hint is it's always going to be slanted away from the rain. So in this situation here, you have the rain shaft that's in the center of your page and out center of the presentation and also to the right, but you have the slanting that's away from the rain. So you can see it's kind of slanting away. Here's a situation here. You have the rain that's actually down the road and to the right of the road, but you can actually see the slanting of the whole wall cloud, the whole shelf cloud that's slanting away from the rain there. Here's the one that's actually, the rain shaft is actually in the center, and the slanting is actually towards you. You can kind of see it's kind of lifting up into your area. It is a very big, large feature of the storm. And so I always say this hint is slanting away from the rain, but also it's gonna be tough to get it into your viewer. So this looks like a wide view to get into your viewer. I'm talking about your cell phone as far as taking a picture. You may have to do a panel to kind of take a picture of it, or you may have to do a 0.5 to kind of get it more expanded. And I think that's what this person did with the picture here. They expanded it out to actually capture the whole horizon there to get the whole picture. There's a picture. It all depends on the view of where you're at. Here, I can't tell what's going on here, and it may be a situation that I'm right along where the chef cloud is propagating from east to west, or maybe from right to left here. I'm thinking I'm looking south, but I can't tell what I'm looking at here. So it really depends on which side and which vantage point you're at. Here's a situation where you got the rain shaft that's occurring on the left-hand side here, and it looked like maybe you got some slanting that's going behind the barn there, behind the shelter there, that's slanting away from the rain there. So if this is very difficult to see, you'll see what I'm talking about when we're talking about wall clouds. Do I need to report a chef cloud to the National Weather Service? No, but it's important to identify, to know what you're looking at, so you're not reporting a chef cloud. So now we're going to talk about the wall cloud. That's a smaller feature of the storm. It is right above where the strongest updraft is occurring. That's where the updraft is occurring. The overshooting top is at the top, so you get the downdraft that's to the right there. Not only is spreading out to the right to produce the chef cloud, but you have the spreading out that's going back towards the main axis of the storm, where you're getting that going back into the wall cloud. And you can see the wall cloud feature where it shows the tornado wall cloud, but it also shows that slant there. I'll show it in another picture here, but that wall cloud is going to be slowly rotating. It is the spine of the storm, and so it's going to be rotating on a vertical axis. It must be rotating. So we're back to this picture again. I wanted to show you this one here, so you kind of get back. Okay, now what I'm looking at here, I'm looking at the picture. Look at the shot that's at the bottom, showing the rain shaft to the right, and you show the wall cloud there, and you can see that leaning, that slanting towards the rain, almost like it's kind of dipping into that moisture to get the fuel of that storm, kind of feeding back into the updraft there. So the wall cloud, as far as rotating, is the lowering of the thunderstorm updraft. So it's lowering, but it's the updraft of that storm, and it often precedes the funnel cloud or tornado, and it indicates a very strong updraft. So here's the situation here. You have the rain shaft to the right. You see the wall cloud there kind of lowering, but you see that slant. I mean, that's a strong slant almost to the ground there. And you gotta be patient there to look at it. That's not a tornado there. That's the actual wall cloud kind of slanting towards the rain there. And if you're in a situation, you're out here, this looks like somewhere in New Mexico, maybe the high plains of Colorado, I'm not sure. But it's nowhere near here, I can tell you that. If you have that hue, this picture is not filtered or anything like that. This is an actual picture. If you have that hue of a green hue, that indicates to me, especially if the lighting is on the background or you got a setting sun or something like that, that indicates to me that hue indicates there may be hail in this storm. So rain-cooled air flowing and splits, blowing away and towards, and then back up into the updraft of the main storm. And again, the wall cloud is rotating. Here's the rain shaft to the left, slanting out, and look at that wall cloud right there. You can see that slant back into slanting into the rain. If you're patient enough, you'll see the whole wall cloud rotating. So the slanting towards or away from the rain, wall cloud is going to be slanting towards. Chef cloud is going to be slanting away from the rain. Remember, no need to call in for the chef cloud. Call in for a rotating cloud because they're the precursor of a funnel cloud or a tornado. The other hint here is the wall cloud is going to fit in your viewer. If it does not fit in your viewer, you're too close, especially if it's rotating and everything. You see all those features. it's slanting into the rain, it's rotating, and it doesn't fit in your viewer, you're too close. You need to take cover now. Chef cloud's not going to fit in your viewer. It's going to be slanting away from the rain. And it looks worse than it actually is. It looks like a big spaceship. If you can, and if it's safe to do so, snap a picture and take a video and send it to us. So we're going to talk about tornadoes and funnel clouds. Tornadoes, contact with the ground, violently rotating column of air. Funnel clouds are not in contact with the ground, but both have a rotation on a vertical axis. Tornado clouds may not be visible, so you may not be visible from that standpoint, but you're going to look at the base where there's debris. If there's debris there, that's a good indication. If you're patient, you kind of see you may have some an appendage from the thunderstorm that maybe you may see something maybe from the wall cloud is extending down. You may see some smoothness there of a tornado. So the column may not be there, but the debris may be on the ground. So you're going to look for that contact there. So the funnel cloud is the fast spinning funnel cloud descending from a thunderstorm cloud, but not yet in contact with the ground. So the rotation is the key. Signs of that conditions within the storm are right for producing a tornado. And again, the funnel cloud, while looking impressive, it's not causing any damage. And so this here on the right-hand side is from the National Water Service in San Antonio, showing a smooth, really smooth. You see that smoothness to it, that even in a still picture, you see that smoothness. There's a chance that the funnel cloud may not become a tornado. It may not reach the ground, but it may reach the ground. But you do need to call that in regardless of whether it reached the ground or not. Tornadoes, a rapidly rotating column of air in contact with the ground. We kind of went over that. 1 out of 1,000 thunderstorms produce a tornado. That means we have a lot of thunderstorms across the United States. Tornadoes usually produce very small and defined areas as far as the damage and swath path. And remember, the amount of damage does not indicate whether or not there was a tornado. So we're going to go through some hints here. Rapidly rotating cloud with fairly smooth edges here. You can see the nice smooth edges here, even in a still. And that's how we used to do it back then, because we just didn't have videos. People have snapshots of storms. Camcorders were very heavy back then, but some people had camcorders, especially some of the chasers out west. Now with all the phones, everybody has a camera and has a shot to take a picture instantly. Here's another situation: smooth, rapidly rotating cloud with smooth edges. Here's another one. This tornado may be roping out, may not be touching the ground, but I can't tell behind the tree line there, but it's rapidly rotating. It's very smooth edges. Now we're going to talk about scary looking clouds, scud, cumulus fractus. They're harmless, they're raggedy looking. They may be showing some turbulence of up and down, but they do not rotate and they can move up and down. They're responsible for most of our false reports. Those are the reports that, oh, by the way, there's been a smokestack near my home for the last, been there for 60 years. On this day, it's a tornado. We used to get those calls a lot. We used to get pictures of like that a lot. And even still now, we get some pictures. Is it a tornado? No, it's not. It's probably, it's a smokestack, or it's something that's not there. So here's a situation where it looks very raggedy versus a very smooth, light, and rapidly rotating cloud. It looks very raggedy. It's out of place, showing some turbulence, possibly. Here's a smokestack in the distance, has a cloud deck on the horizon. Quick shot, people may think it's a tornado in the distance. Here's another scud, looks very raggedy versus a smooth like a rapidly rotating cloud. So it's not a feature that you're going to see, but we do get a lot of false reports on that. So we're going to talk about name that cloud. We're going to go ahead and talk about this. I know in person we normally kind of look at this, and I guess maybe put some questionnaire on there, but we're going to talk about name that cloud. So is it rapidly rotating along a vertical axis there? So we're looking at this feature here, maybe something kind of dipping down. It looks kind of smooth there, so I would think it's probably smooth. Is it touching the ground? I don't see anything touching the ground there, so I'm going to say no. I'm going to say probably it's a funnel cloud. Go to the next one here. Slope towards or away from the rain. So we know the rain is actually in the center of the page and maybe to the left. And then you see this slanting that may be occurring. Looks like it's slanting away from the rain for the most part, kind of over the highway there. The guy's taking a picture there, kind of slanting away. So if it's slanting away, then more than likely it's probably a chef cloud. Now we got a cloud here. I'm not sure what's going on. Looks like it may be the rain is behind a building on the right there. Looks like it's reaching the ground. There's a lot of raggediness going on here. And I'm going to probably say that, it's probably showing a lot of rain, but it's very raggedy. And I don't think it's touching the ground there. So I'm going to say it's scud. So here's a shot that that was from last year, I believe, in North Carolina. Is it rapidly rotating on a vertical axis? I don't think so. It looks like it's almost cascading over something here. This is a real shot. So I'm going to think it's ragged. Is it touching the ground? I don't know. I can't really tell, but it looks very ragged. I don't know if I want to go any further than that. So probably not. I'm going to say this is scud. So we got this feature here. Is it touching the ground? But take a look at this. It looked like it may be touching the ground. So yeah. Is it rapidly rotating on a vertical axis? Is it smooth or is it ragged? It's hazy. I can't really tell. But I was patient enough to see that something's touching the ground. There may be some rotation. I can see something there. So even without that, I know that something touching the ground. There's some rotation at the surface. Do I need that smoothness there? I don't know. But I know that's a tornado. So how can a spotter best help the warning forecasters? As soon as it's safe to do so, report to us as quickly as possible. Never assume that we already know about the reports. And so we always tell our partners, our emergency managers, our first responders, don't assume that we know there's flooding going on. Don't assume that we know that there's a tornado that hit a location or hail or anything like that. Give us a call. And I'm going to give you that information too. Know how to get your information and remain weather aware. So you got those national sites to look for outlooks. When we communicate with you through the legacy text, but also when we're talking to you as far as when to activate. So we have that information there. You also have the, and I didn't go over this, each site, each forecast office is gonna have that graphical hazardous weather outlook. So not only for Northern Ohio and Northwest Pennsylvania, if you zoom out and then go to your particular area, you're gonna have it for your area too. And those pages are actually, a lot of emergency managers really like those pages because it has a date and time of when those grids were actually created right from our office. And so you can see that. For reports other than tornadoes and significant damage, flooding, consider sending reports digitally through our webpage, and I'll show you how to do that, the webpage and actually the address, social media, and email. Pictures and videos are helpful and they're greatly appreciated. Keep the report concise but descriptive. Time, event, location. So we talk about time, event, location. Anytime there's penny-sized hail or larger, I would say anytime there's any kind of hail, please report it to us. 50-mile-per-hour winds, wind and lightning damage, flooding, tornadoes, funnel clouds, and wall clouds. No chef clouds. As far as reporting hail, time, event, location, do not report hail in marble size because Texas marbles are bigger than other marbles. And so you don't want to use marble size. You do want to use coin size or sports ball size, meaning like ping pong or meaning like baseball size sale or tennis size or golf ball or softball size sale. Do not use marbles. Time, event, location. For wind, lightning damage, wind, or tornadoes. Time, event, location for that. Want to be specific on the time. We can actually tell, at least for wind, sometimes the wind damage has occurred and you take a picture of it, and we can go back on our radar and actually get an approximate time of when those winds actually reach the area that the damage that occurred. This is kind of a time or a estimation of wind speed. There's a lot of them online you can look at, but this gives an idea of some of the impacts that occur sub-severe, 58 miles per hour. As you can see, large branches breaking off at 47 to 54 miles an hour. So it's important to kind of look at some of these and see some of the estimation of wind speed that occur well below severe limits. So a lot of times we are forecasting for impacts, especially when some of these severe storms are approaching. Maybe it's in a crop season or something like that, because if it's protecting life and property and winds of 40 miles per hour or 50 miles per hour approaching, they're in an open area and those winds collapse on a crop, it'll destroy the crop. And so even though it's not severe as 58 miles per hour, but the impacts are there. So we may issue for severe thunderstorms that may not approach the severe limits depending on what's it's affecting. Time, event, location for wall clouds, funnel clouds, and tornado. Again, that's the event. Time, event, location, tell. For flooding, oftentimes when you approach a flooded road, it's already occurred, and I don't want to be in a situation where you got out there measuring. You may want to report this to the police department or the 911 and say, hey, this road is flooded, so they can get people out there to put barricades and make the road safety, make detours, and make the appropriate action. Time, event, location, you want to get that information to when you're calling your local officials there. Remember, lightning does not make severe storms, and we do not issue for severe thunderstorms for lightning, but lightning is a killer. So when thunder roars, go indoors. Lightning damage to trees or structures, that's when you report. Do not report for lightning, no matter how vivid or intense it is. That was just a kind of a, we kind of tweet this out more or less on all of our social media there. But I'm going to go ahead and actually give our unlisted number to our news spotters. That's what you are. That's our unlisted numbers. Do not call those for climate information about a wedding in June. Do not call us for a fishing report. That's for reports of severe weather. So that gets right into our line, into our operations here. You'll be talking as soon as the pickup. There's no tree or anything like that, phone tree. That goes right to our forecasters, and they're there to pick up the call and answer and take your report. Twitter, if you actually you add us or whatever, you actually tag us or you actually talking to us or DM us. If we like the Twitter feed or like your Twitter post, that means we have your report. If you want to email us, stormclee@noaa.gov, but that's a little bit slower. We may not respond as quickly on a Stormclee, but we will get that information. And also on Facebook, we're on Facebook. You get that information to us or DM us, we'll get that information as well. So we talked about the web farm as far as reporting it. This is the website that's right above it. If you've registered online, and most of you, if you're on here, you're already on it, the local programs, if you go all the way on our website, on the right-hand side, it's going to be the last one, submit a storm report. That will get you to this page here, and it's actually self-explanatory there. You just kind of tag your location of where the hail report or where the severe weather report occurred, and then it'll actually find the lat and long for us, and then you fill in the information and send it to us. It's just that easy. And be careful with this one. We've had some of the people that actually went in here and put in a report, a false report. I think that was from Arkansas. They did it for Ohio. Oh, by the way, your IP address is attached to your phone, is attached to your PC, your laptop. yeah, we know who reports it, so be careful with that. Um, we don't get a lot. We don't get that many false reports. It's just that I remember that incident happened last year. We do work with the ham operators and the Aries group here. So we're in um, district 2 that comes into our office, and we work across northern Ohio and northwest Pennsylvania. Volunteers, Coco Ross is kind of our campaign for March. I'm not supposed to say March Madness, but that used to be the thing, but actually looking for more volunteers. Coco Ross is more or less a network of volunteering, measuring for precipitation, snow, rain, sleet. And so they're looking for that group of network. Actually, March 20th, that has passed, so that's an old one. I need to kick that out as far as the Coco Ross webinar, and that's old. So, but anyway, you can go to the website, just type in Coco Ross and you'll get that information. Actually, Zach Zefkovic is our Coco Ross specialist. He's our snow guy. Again, it's a kind of a grassroots, nonprofit, community-based high-density precipitation network. We take observations daily, and we have over 220 Coco Ross volunteers across northern Ohio and northwest Pennsylvania. MPing, meteorological phenomenon identification near the ground. This is actually pretty good, especially right around the time when temperatures are right around freezing and there's some precipitation around, and there may be a case of maybe some frozen or maybe some freezing rain or sleet or snow. This app is on Android and Apple Store. It's actually a collaborative thing we did with Oklahoma, University of Oklahoma. It tags the time and location when you do reporting. It's not for severe weather, but it's for different types of weather, like fog and like I said, the snow reports and stuff. This is very helpful for some of the superintendents across Ohio, and they kind of look at this. Or maybe you're driving out and you kind of, do I want to venture out or do I want to wait until it warms up? Is it treacherous? And people are reporting what they're reporting when they're stepping out. Okay, I'm reporting sleet. I'm reporting rain. It has time reports in there. And this app will light up like a Christmas tree right around a time when it's pretty close to freezing and there's precipitation around. In summary, time, event, location. As a spotter, you guys are very important to us. I appreciate your time and know it's been kind of non-interactive. It's online. It's at your own pace. Right now I have 3:48, so I managed to get it under 2 hours here. For your certificate, get your certificate, you could actually use the QR code or use that website. And of course, it's on there on that schedule there. You can actually pick up that information there to get your certificate. We do not assign Skywarn numbers anymore. So if you're registered, we will have your information and actually put it in. And if you're out of our area, I will try to forward it to the areas that you're in. And you may want to go ahead and actually, hey, I took a online course under Cleveland, but I'm in your area, but I'm going to look through the registration on Friday, have a chance, and try to forward as many as I can if you're outside the area to your forecast office. That is all I have. I'm going to try to see if I can go in here and open this up and see if there's any questions here. I don't see any questions, but I'm going to open it up a little bit more to see if there's any questions. If you want to drop a question in there, I'll be able to answer that question, and I may answer it out loud or just read it out loud here. Let's see here. Okay, let's see if I can actually tear this off. Okay, I see some of the answers here. Flooding and heat. Yeah, I see some of the, will the lecture be available to download as well? I will try to make it available. It's being recorded. I just need to convert it to a YouTube, and I actually may do a YouTube. I know the one for 2020 is on there, so we can go ahead and upload that one, new one there, because there was a lot of changes that we did make, especially for the national resources there. And what we found out, especially in person, that a lot of the new spotters were unaware of the national resources that are on there. So we'll try to download that and make sure that's on there. I'm going to look down and see if I see some more questions here. I'd appreciate that. Can you give the QR code again? Let me see if I can get back there. And there's the QR code. Oh no, I didn't know. I didn't see that from Ashlyn. Howard, I will, again, if you do not have the audio, I'll try to get it uploaded either by Friday or Monday. I'm out of the office tomorrow and Thursday. We do have a Skywarn in Huron County on Thursday, and there's some engagement tomorrow. I'm not going to be in the office tomorrow. On Friday, hopefully I can be able to catch up with it and actually put it out and have that link available if you did not hear it on the audio. I see most people were able to hear it, and that's good, but I know maybe if you had some technical difficulties, I'll make sure it's on there so you can hear it. Okay, so I showed the certificate on there. I'm gonna stay on until the top of the hour, and then I'm gonna end the presentation. I appreciate your time. Thank you very much. You know, the online feature, and I did want to talk about this. If you're interested in really, you want to get into the weeds, you want to really look at some things as far as weather, what we look at as far as severe weather threats and stuff like that. April 6th from 2 to 4. If you go to the registration, it's a different registration. Each of these online registration are different. It's going to be done through webinar, and we have a guy. He's a very sharp guy. He's going to present the advanced course. Is the first time we offer the advanced course, and you guys have been asking for the advanced course for some time. And I noticed on social media and even in my emails, hey, when are you going to have the advanced course? And what we noticed that there hasn't been a lot of, there've been some questions about advanced course, but it's not from one location, so that's why it's online. So April 6th, 4 to 6, that's for the advanced course. And as of right now, our registration can go up to 1,000. We have 175, and so we're nowhere near that. But if you want to sign up for that as well, it is prerequisite that you went through. And if you hear my voice, you already went through this one here. It's a nice prerequisite to kind of cover that and a lot of severe stuff. A lot of if you really want to get into the weeds on everything. Okay, I'm gonna probably at the top of the hour, I'm gonna end the presentation. I appreciate your time and thank you for coming out. It looked like we had a pretty close to 100 people in attendance, and I'm looking forward to getting you guys as new spotters, get that information in there. And thank you very much for your time. Have a good day.